Assalamualaikum and very good afternoon to all participants today. I'm Kasma, Secretary from MOGEC. I will be the host for today's webinar. On behalf of MOGEC Council members, I would like to extend a very warm welcome to all participants to this MOGEC webinar titled Creating Efficiencies with Digital Twins, which will be presented by Digitex and James Visual AIS. Today's webinar will be using Teams live event. We encourage participants to send your questions at the Q&A chat box, and please state your name and the name of your organization when submitting your questions. To begin our webinar today, I would let President of MOGEC, Engineer Abdul Rashid, to deliver his opening remarks.
Salam sejahtera, good afternoon and good morning, depending on where you are. You attending this webinar from. Welcome to another webinar hosted by the Malaysian Oil and Gas Engineering Council, MOGEC. This time today, we are doing this in collaboration with the Institute of Engineers Malaysia Terengganu Branch. Today's webinar will be, as mentioned earlier, jointly presented by Digitex and James Fisher Asset Information Services. As written in our flyers, this webinar focuses on the use of AI to transform legacy data into digitally intelligent data using the latest 3D technology to create a replica that provides a key foundation layer for digital twins. Hence, the title of today's webinar, Creating Efficiencies with Digital Twins. I'm also very pleased to inform everybody, because of technology, we are able to hear 3 speakers from 3 locations and in 2 time zones presenting today's webinar. Very quickly, Richard is in Perth, Ruth is in London, England, and Nick is in Aberdeen, Scotland. I'm pleased to also inform everyone that more than 100 participants have registered, and hopefully everybody can log in. So I have met Richard personally, both in Perth and in Kuala Lumpur, and I'm looking forward to meet Ruth and Nick, hopefully also in Kuala Lumpur when the borders open up again. I think Mahmoud will say something about MASIP and Digitex collaboration, but I'm very pleased to say that Digitex and MASIP has started having their footprint in Petronas through the various projects that they have secured, mainly in rapid project in the southern part of Peninsula Malaysia. I wish them more success in the coming future. My special thanks to Kasma and the MOGEC Council for organizing this webinar today. And my sincere thanks to MASIP for sponsoring this webinar. For everybody's information, there is CPD hours that is allocated for attending this webinar. Please contact our secretariat for information. With that, I now hand this webinar to Mahmoud for him to introduce MASIP and Digitex. Over to you, Mahmoud.
Okay, Assalamualaikum and good afternoon to everyone. Thank you to IR Abdul Rashid, my good friend, the president of MOGEC. Really appreciate your introduction just now. And thank you also to IEM, the Institute of Engineers in Malaysia again, for the CPD point honored for this program. So I will start with a bit of introduction about MASIP, a few minutes, maybe a few half minutes probably. MASIP is a Malaysian company based in Terengganu, and we are expanding, inshallah. So over the years, MASIP core business is basically in engineering and project delivery, mainly in oil and gas industries. In this digital journey, we have expanded our business and formed collaboration with specialists in digital asset, and also value-added engineering in data analysis. So yes, we have established our global partners in this exciting digital journey with Digitex, and James Fisher, Asset Information Services. We have embarked on digital asset and digitalization projects for oil and gas industry in Malaysia. Digatex and MOGEC has delivered few projects in Malaysia for Petronas, utilizing latest technology of artificial intelligence to provide value-added solution. So really hope today's webinar will be a very good session for everyone with our panel of experts. So with me today, first is Richard from Digatex Australia. Ruth, Christy and Nick Cronin from James Fisher, Asset Information Services UK. So they will initially share some case study and demo for our knowledge and reference. So a bit of introduction about our speakers today. Richard. Richard is a co-founder of Digatex. Okay, Richard holds bachelor and master's degree in electrical engineering, including an MBA. He's also a fellow of the Institution of Engineering Technology in London. And for Ruth, currently she's holding a position as Business Development Director. She has over 15 years of oil and gas industry experience and excellent track record in management and project delivery to some of the world's largest organizations. And our last speaker will be Nick Cronin. He's a business development executive. He has over 6 years of experience and services in sales with excellent track record in management and communication. So that's a brief introduction about MOGEC and our speakers today. So thank you so much. So our next agenda will be a presentation by our technical team. So now I would like to invite Richard, Ruth and Nick to proceed with next agenda to do the presentation and demo. So please, Richard.
Right, thank you very much indeed, Mahmood, for those kind words, and to Rashid as well. And likewise, we're looking forward to coming back to Malaysia when the travel all opens up again, hopefully in the not too distant future. And thank you very much indeed to MOGEC for hosting this webinar and inviting us to present. Really appreciate that. And welcome to all the attendees. Great to see so many people attending, and we really hope that you get a lot of value out of this afternoon's session. The agenda that we'll follow is we'll start off with understanding why we need digital twins in the oil and gas market. How do we address the challenges? Then some case studies. So what has actually happened to date? What is really available now? And a little bit of a demonstration of what the future looks like. And then we'll end up with questions and answers. At the end of the presentation, the slides will be available for you to receive through the MOGEC secretary. And at the end, we will do a demonstration of some technology which displays some of what we're talking about in the presentation. All right, so what are the key learning points from the webinar? Well, first of all, you'll learn why we need digital twins in oil and gas. Secondly, what are the blockers? What's stopping the adoption of digital twins? Why doesn't everybody have them? And then a little bit about some breakthrough technologies we'll talk about: the visualization, drones and robots, artificial intelligence and machine learning, and cloud computing. At the end of the day, it's really all about the data. And that's what you'll get to see throughout this presentation. All right, so along with low oil prices, we have a number of challenges which we have to address. We start off with safety. Of course, we want everyone to get home safely every day. So that's our prime focus. But despite the low oil price, there's still a massive focus on cost reduction. We see reorganizations, we see mergers of companies, and we're seeing massive pressure on employees to reduce cost. There's also a huge focus on reducing the carbon footprint. Investors are now moving into other areas away from oil and gas, so that puts more pressure on our businesses. So how can we help to reduce our carbon footprint? research has shown that employees in the oil and gas sector spend at least 20% of their time just looking for data. So that's 1 in 5 employees spend their time just looking for data. Now, this is very much a hidden problem because nobody fills in a timesheet and says, I spent 2 hours looking for a PNID today. That's just part of the process. So it's a hidden problem, but a very, very expensive problem to have. So why are we in this position? Well, a lot of it stems from the fact that there are multiple data handover points throughout the life cycle of our assets. If we were to build a new facility, we'd start with a concept study. And we would then, in that concept study, it'll be reviewed, and all the data, drawings, and documents will all be handed over to the operator for review. And then, if the decision is made to proceed, we'll then go out for front-end engineering design. And then it'll go to probably a different party because different skills are required. So the feed is done, and normally you come up with a 10% or whatever the value is cost estimate. That comes back to the operator and the partners, and they review that. And all the data is handed over in the form of drawings and documents and perhaps some initial 3D models. And then after some time, when the decision's been made, when we have financial investment decision made, we'll go out to an engineering procurement contractor to design, procure the equipment and construct the asset. And then we get to the end of that, there's a huge data handover, that's why that's a little bit bold at that arrow, of all the information for the operator. So by the time you get into operations and maintenance phase, there have already been multiple data handovers. And every time we do a data handover, we lose quality of information because that's just the way it is. And of course, throughout the operations and maintenance phase, we are continually handing data over to third parties, getting it back and having to transform that. And then we go into decommissioning. So the landscape that we end up with is as shown on this diagram in the bottom right-hand corner. We have lots of unstructured data. Unstructured data is data which is locked up within drawings. For example, on PDFs, on photos, on scans, and we have equipment data, material data, which is notorious to get any real structured data on. And we have all of this information, if you like, in multiple formats. Word documents, Excel documents, PDFs, AutoCAD, MicroStation, you name it, we've got every format there is known to humankind in the oil and gas sector. And this data that we have is all stored in multiple systems. Some ERP systems, some maintenance systems, some engineering design systems. So we've got this data anarchy, really, we call it in our sector, unfortunately, where data stored all over the place, stored in multiple formats, and stored in multiple systems. And that's why we have this massive problem, circling back to the top right-hand figure, where it takes us so long to find any data that we're looking for. So in our facilities that we have, for example, offshore facilities, they're mostly remote. So when we have a failure or a suspected faulty component, we don't just walk over and go and fix it like in a lot of the other industries, such as manufacturing. In this case, if it's subsea, it could be something that's 1,000 meters below the sea. So we can't just walk out there and fix it. But our data is still in a mess. Let's have a look at what other industries do. Let's look at the space industry, for example. And yeah, this picture you have here is of the Perseverance, the Mars rover, which is currently out on Mars, sending back these amazing pictures and doing some incredible investigation out in Mars. Now, the way that NASA operate is when they start a project, for example, to build the Mars Perseverance rover, they start with a digital twin right up front. So they have a digital model of what they want to build. Then as the design progresses, they build on that model. So they don't have all these multiple handover stuff. They still have external parties working in, but they work in a single central model. So they are constantly monitoring how every single sensor on Perseverance is performing, because they have a real problem. If a sensor fails on Perseverance, you don't just launch another space rocket and go up to Mars and fix it. It's not quite as practical as that. So they've really perfected this, but we haven't. So what is this digital twin all about? Well, we believe in a concept we call data recall. That's really what we're trying to do. So when a piece of equipment is about to fail, and you might have a very sophisticated operational system or maintenance system monitoring your asset. And when it says, based on past experience, this particular valve, SDV 2007, as shown on this drawing, is about to fail. What does the maintenance person or engineer need to do first of all? Well, they need to look at the drawings and documents. So they need fast access to the data, and the data hidden in all these different documents that we've got. Now, let's look at the PNID and see where it is in the flow. Let's look at the general arrangement drawing to see where it's located. Let's look at the material master data to see whether we've got a spare in the store. Let's look at the maintenance schedule for this particular valve. And then, of course, we are human beings. We're used to working in a 3D environment. So it'd be very good if we could have a look at where this particular valve is on the asset. So this is all about accessing data, sharing it and consuming it, and very often, in most cases, remotely, because our assets are mainly remote. And then, of course, linking this virtual environment, if you like, to the real world. So on that slide there on the left-hand side, you've got the PNID, which is a virtual world. And then the right-hand side, you have an image of the actual valve out there on the site. And of course, it's really, really important. And please, if you forget everything else I tell you, to remember this point is that you need the ability to reuse the data. And that's very, very important. So we're not just doing a very quick OCR and work out where that tag is. We need to be able to extract the data so we can use it for other purposes without doing this laborious exporting, mapping and importing processes. So what comprises a digital twin? Well, out on our platforms and our facilities that we have a number of elements. We have drawings and documents. Now, these drawings and documents are layouts, they're drawings, they're schedules, PNIDs, isometrics, you name it, we've got them, and in multiple formats. But then we have databases and spreadsheets. Engineers love building assets, databases and spreadsheets. So you'll have hazardous area schedules, you'll have critical equipment schedules, you'll have alarm and trip schedules, etc., and all that data is normally in some sort of database. And then we have a whole lot of 3D models, and these could be CAD models, which were CAD model, of course, stands for computer aided design, and a CAD model is used by engineering contractors to design and build the asset. And there's two huge benefits they get from it. Number one is space management, because they need to make sure that nothing clashes when they get to site. Because if you've got a 12-inch steam pipe, it's very expensive to move it if it's going to clash with a piece of equipment. And the other one is material management. If you can get the materials right, you can be very, very efficient during the construction of the asset. And of course, when you get into operations, this plant is changing constantly. And not everybody updates their CAD 3D model to as-built and then maintains it. So that's where technologies such as photogrammetry, which my colleagues Ruth and Nick will talk about later on, come to their own, where we can take a digital photo and that can be used to find your way around the asset. And of course, there's laser scanning as well if you want the detail, and the technology's really moved on. We'll talk about that a bit later on. But then there's supplier or vendor catalogs. And these are a real challenge because they're normally scanned PDF files, which are not searchable. And the data that you want is probably on page 278 of 800. So traditionally, it's very, very difficult to find the data within vendor catalogs. And then we do, of course, have some intelligent schematics. You have intelligent PNIDs, intelligent isometrics, etc. So that's the landscape of the engineering data, and some people will call that a digital asset. And what the digital twin does, as shown in the middle there, is it links this all together. But it's a massive challenge to be able to extract the data so you can create that linking. And that's what we'll talk about just now. But of course, this all, once you've done that, that all feeds up into the overall digital twin of the asset, because you need to maintain the asset. And with that, you need to continually create work packs. You need to be able to tell people what you do. You need to group equipment together, and that needs the engineering data to be able to do that. Material master or equipment management, really, really important part. So, and we'll talk a little bit about duplicate items later on in the presentation. if you have duplicate items in your store, it's costing you more to store them. It's costing you more because you're going to buy more equipment, which means more equipment has to be manufactured, and that's increasing your carbon footprint plus your costs. So focusing on that, you can have some significant savings. And then there's the engineering aspect. Engineers need to check, for example, if a pump has failed and that pump is obsolete, then engineering need to check to make sure that whatever's been proposed will do the duty and do it safely. Then there's the inspection. We see a lot of computer programs coming online now about 3D inspection management. There's a lot of work being done in the risk-based inspection area, where we'd really like to be able to take an isometric and mock it up and say, right, here's an inspection point, here's all the weldlets, here's all the welds, these are the flanges. But when you've got dumb PDF isometrics, it's very difficult to do that other than manually. Then in operations, and there's been a lot of press coverage, a lot of articles recently about artificial intelligence being used in the operational environment, which is great. And the very, very clever systems out there monitoring all the equipment and coming back to say, well, this piece of equipment is about to fail because we've picked up a vibration, and that's probably the bearings, and that's probably being caused by an imbalance in the voltage in the electrical system, and that's really good information. But of course, the engineer at the end of the day has to look at this and then drill down into the engineering data, which was shown on the previous slide. So that all has to feed up into this digital twin. And of course, once we get that right, the opportunities are huge, because if you start on the top left-hand side, we have collaboration and integration. I think COVID-19 has certainly showed us that working remotely is possible and actually very, very successful. Well, we're running this webinar today with the UK, Australia, Malaysia, and whoever else is dialed in. I think there's some people in the UAE as well. So there's multiple locations. So we have the sort of distributed work environment, smart rooms, the extended enterprise, all what we're doing right now. But we need the data to be able to drive that. If you cannot view the PNIDs electronically in a cloud-based solution, then you're not going to be able to work remotely. Well, on the top right-hand side, we have smart access to granular data, really, really important. We're with a big Malaysian operator this morning. They were talking about their 7D system. So things are progressing very, very rapidly in requiring granular access to data. And their question to us was, they've got thousands of PDF PNIDs. How can we link them in to their 3D model so they can have smart access to their granular data? And we'll talk about how we do that just now. Then there's the analytics, and of course, very important to have these facilities available remotely, and to do that we need a cloud environment, and that's where artificial intelligence comes in, and we'll explain that in the next couple of slides. Then of course there's the real-time remote monitoring and operation. There's the Internet of Things, there's radio frequency ID, there's machine to machine, there's centrollers, which are sensors and controllers together. In the IoT world, drones and robotics being used dramatically now to do things like looking at gas emissions, which you can't see, you can't smell very often. But if you can have a drone doing the sensors on that, that can do a lot. But of course, all of this requires the underlying data, which we spoke about on the previous slides. And of course, adding to this, as human beings, we interact in a 3D world. If we have this capability of being able to see our asset in the 3D world, then it makes us feel comfortable. As I said earlier on, the 3D CAD models are not always as built, and so they can't always be relied on to be exactly what is out there on the plant because of the rate of change out on an asset. Robots are often being used now for remote investigation in hazardous areas. We see that happening a lot more. And drones, as I said earlier on, for gas leakage detection. And a wearable technology, absolutely amazing progress has been done here. So as a maintenance person, you can go out into the field and you can look at a piece of equipment, it'll scan the tag number and call up the maintenance manual for that piece of equipment. So things are moving very, very quickly now, but it does require the data to make all of this work. And that brings us to photogrammetry. Why would we? That's been around for years and years and years. It's not a new technology, but there have been some massive advancements. We can now do acquisition very, very quickly, so we can capture a plant very quickly. The updates can be done by the operator, so you don't need to call back the company that created the photogrammetry model for you. But the big plus is it provides an as-built view. And certainly I did quite a bit of work here in Australia with Woodside a few years ago. And what they found was that when they started looking at the photogrammetry model, they picked up safety issues. And that was a huge advantage to them. They wasn't designed for that. They captured it in order to do maintenance, but they found there's a very good side benefit. And of course, with these operations or these plants being remote, it means that you can view this in your office or in your home as you are sitting right now. And of course, we can now link the documents and the data to the 3D model, and we'll show you that just now. Of course, that gives a huge advantage, because if you're looking at this particular valve in the 3D model, photogrammetry model, you can click on a button and open the PNID or the general arrangement drawing or the drawing or the loop diagram, whichever drawing you want to have a look at. And that's what brings it all together and makes it very, very good. And of course, with the latest technology, I'm sure Ruth and Nick will talk about it a bit later on, you can bring laser scans into this as well. So you can combine this all together, so you're not locked into a single technology. All right, so we've mentioned artificial intelligence and machine learning a few times. What do we mean by it? Well, we thought we'll put this is not our slide, it's a slide produced by a prominent AI person. And AI is defined as a technique which enables machines to mimic human behavior. So just as an example, if I showed you my mobile phone, you would look at it immediately and you say, yes, that's a mobile phone, and it's an iPhone. Now, how would you know that? Well, you'd know that because you've probably seen one before, you probably even got one. And that's the same as what we're doing with machines. We're teaching them, using artificial intelligence to identify objects. So if you looked at a PNID, you would look and you say, oh, there's some lines, there's offsheet connectors, there are valves, there are instruments, there's equipment. How do you know that? That's because you've seen it before. We're doing exactly the same here. And machine learning is the subset where we use advanced statistical methods to speed up the process and make it much more efficient. And deep learning is the subset which makes the computational multi-layer neural networks feasible. Now that's very, very technical, and we won't go to it in this presentation, but it's certainly one of the techniques that we use. All right, so what is the value proposition here? Because we can't do anything quicker or cheaper, as we know from our opening slides, then we're not going to get approval to go ahead. So the way that we can approach this population of the digital twin with engineering information is to take that engineering information in whatever format it is, that this unstructured data in the terms of documents, drawings, photos, etc., and the equipment, material data, material master data, anything we have, we'll feed that into our artificial intelligence and machine learning platform. Now that is combined with the domain knowledge, which is the focus on the business and the data needs. So the human being goes in and says, right, we've got these drawings. These drawings are called PNIDs. And on there, you'll find these things that are called instrument bubbles. I'm interested in getting all the instrument bubbles off all these 100,000 PNIDs that I've got. The machine would then be able to do all the heavy lifting of that repetitive task, process it in the cloud. We need cloud computing because this sort of process does multiple processing and needs very powerful processors, and we don't want to have those servers lying around in our office. So we use cloud computing to enable that to happen. So at the end of the day, when we've done this processing combined with our domain knowledge, we then have a connected, consistent information set of digitally intelligent documents. So to wind back to the beginning of the presentation, instead of spending 20% of your time looking for data, it's available immediately. So let's look at some examples. Here's an example. On the left-hand side is an image from the James Fisher AI system, photogrammetry system called R2S. And you'll see it's a very, very clear picture of a junction box. That junction box number is 1A1I JB0460. And what the AR platform has done on the right-hand side is it's gone and identified all junction boxes. So the domain specialist has said, right, I'm interested in junction boxes. This is what it looks like. Go and extract them. So it's identified all those junction boxes in the tree view there, 42, 41, 43, etc., and has highlighted them on this general arrangement drawing. So you could go in and say, I'm looking for junction box number 32. It'll open up that drawing, it'll zoom into that item. Then you might say, I want to look at the 3D model associated with this junction box. Clicking on that link would take you to the Photogrammetry 3D model, open up the right spherical and zoom into that item for you. So what we've done here is created the digital twin by linking the processed 2D drawing, the general arrangement drawing, to the 3D model. And that's then enabling us, when the system or the operating system says there's a problem with junction box 32, the engineer can go in, or the maintenance person can go in, type in I want junction box 32, and the data is available and you can see it in 3D. We can also nowadays do this with PNIDs. So here's, for example, a shutdown valve, SDV 2007C, and you will see on the left-hand side, the machine in those square colored boxes is what the machine is identified. So it's identified the shutdown valve, it's identified a flow control valve, it's identified the lines, it's identified all the objects that has been told to go and identify. And that could be a scanned image, it could be a dumb PDF, it could be a JPEG, it could be any format you like. If it's an intelligent PNID, well, then we've got more data we can use, but it doesn't have to be. And on the right-hand side is an image of that shutdown valve, the same one's SDV 2007C. So you can see now, you can go very quickly, you can start off in the Photogrammetry 3D model and go back to the PNID, or vice versa. Now, this is a really important slide. This is a very simple drawing. It's called an isometric, and it was just a dumb PDF isometric. And you'll see in the top left-hand side that the AR platform has detected welds, welderlets, elbows, lines, off-page connectors, etc., and flanges from this dumb PDF drawing. And you will see that call out there, which I've just shown, where the machine has identified that flange because it's been taught how to do it. It's identified the endpoint, so we can navigate to the next drawing. You can even put inspection points onto this dumb PDF isometric and number that inspection point as you wish. And here's the crux of it all. The AR platform has extracted that data. So we've taken an unstructured PDF document and created structured data. So you can see there's the fluid category, the diameter, the area, etc., all held within the database in the cloud. So we can now repurpose that data, for example, to go and do inspections, to go and do maintenance, do whatever we want to do. Here's a case study that's taken from a major EPC wood, where there's a phenomenal savings were made. This is a really tough project that they had executed in the Middle East, and they come to the end of the project, and the client wanted all the data into their smart system. And of course, all these drawings have been done over many years because there was a lot of unrest in the area and multiple contractors had been involved. There were different tagging systems, so it was very complex. So they had estimated it would cost $370,000 US to carry out this piece of work to extract the data. And a time they expected to take was about 50 weeks. And using AI and machine learning, it was executed in 4 weeks for a lot less money. Another one from Wood as well is this one, where this is a PNID once again, and you can see the colored boxes is where the AR platform has identified items. So this is using artificial intelligence to find those items. But more importantly, if you look in the bottom left-hand box with the red square around it, you will see that the machine has said, right, well, this is a pump PBB 7305, but it's also got some data in a table at the top. So I'll extract that as well. So now all together in the database underlying the AR platform in the cloud, we have the tag number, the description. It's gone and looked at the symbol library to say this is a double acting diaphragm pump. We've got the capacity because it says so in the box at the top, and it's got one spare, and the material is stainless steel. So what we're doing is taking this dumb data and making it intelligent and making it available for reuse. That's real, true digital twin availability. Material master data is notoriously difficult to search because the material master data in the ERP system is normally just text, free text search, which has got commas or semicolons or hyphens between it, and very difficult for the human to search. So we have used our AI platform to enable finding of duplicate entries. For example, the top 3 entries there, I've just hidden the operator names for confidentiality reasons, but the top item has got a part number, which is in the middle column, and you will see that those 3 items all have the same part number. So now you've got the opportunity to say, well, if that's the same operator, those items are actually duplicate items. And that's really, really important because duplicate items are very difficult to find normally, but they're very, very expensive as well. You've got to store them, you've got to maintain them, you've got to count them every year, and it means that you're ordering excess stock. It's a huge opportunity for cost saving. And also the ability that it gives you is to be able to share spare parts between operators. Australia is doing this between Chevron, Shell, Woodside, Impex and Santos. The UK have started with Spirit Energy coming on board, BP, and a lot of other operators are looking into this as well. So huge opportunity to drive down the cost. All right, so that leads us on to the linking of the digital twin to the 3D model. And I'm going to ask Ruth now to talk through the case study, real life case study using a tier 1 operator where significant benefits have been achieved. So over to you, Ruth.
Thank you, Richard. Yes, so this slide represents one real world example where international operator BP adopted asset visualization software that was capable of providing a photographic virtual walk around of their FPSOs in Angola so that personnel could view the sites in real life detail, but it was also capable of integrating a large amount of data from other systems and reference points so that the data could be seen in the context of the photographic model. The support teams for these assets were onshore in Luanda and in the UK, and physical access to the site could only be carried out via routine boat trips at certain times of the week. Levels of people on board were limited by bed space, as is usual, and like everyone else in recent times and through all of last year, travel was further complicated by COVID-19 restrictions. So as well as these travel and access challenges, there were also challenges around the vast levels of unstructured but valuable data and disconnected management and operational systems. So this meant, again, that a lot of time was spent looking for information and then ascertaining whether that information was actually accurate when it was found. Can we move on to the next slide, please, Richard? Thanks. So as you can see on this slide, the operations team elected to implement a digital twin platform for both assets and integrate it with existing systems, ALIM, SAP, and their 3D model viewer, UPV. They also went through a process of screening and evaluating data from their 3D models and 2D drawings to verify and organize that data and then link it to the visualization software. So here we can see an example of what that looked like. You can see that the data in context of the photograph, and we can also see it linked to the mother system, if you like. So as illustrated here, all the systems containing the data relating to that piece of equipment could actually be linked through one information hotspot and then potentially accessed out of the visualization system as necessary. So really providing a much easier way to find and understand the information connected through a variety of different systems. So we can just go on to the next slide again, please, Richard. Thank you. So this solution meant that in just a few months, they saw huge savings across their operational costs, and projects that had been stalled due to COVID-19 restrictions were able to start again. And ultimately, data search time was reduced by around 20%. Unlimited access to the software meant that all of their contracting companies could access as well and use it for their own different purposes. So in just 6 months, they had over 150 users, and they racked up over 1,000 hours in user time in the system. And they quoted that they had increased efficiency by around 90% and saved $1 million, contributing to their net zero environmental target also just within the first 6 months. Ultimately now, obviously, you can see on the slide there, they have a lot more users now, for example, but really great results in a short amount of time, and continue to use it to much more easily find and work with the other important data systems and sources that they have relating to those remote assets. Thanks, Richard.
Wow, thanks, Ruth. That's absolutely incredible, and that's a real life story. So very, very good indeed. All right, so let's now have a look at what the future looks like and what's available right now. So we can do this demonstration in 2 parts. I'll take you through what the how we can find data quickly, and then my colleague Nick will take you in a bit more detail into the photogrammetry side, because there's some amazing technology available there now. All right, so what I'm going to do is, we mentioned the shutdown valve quite early on, and we said that research has shown that employees spend 20% of their time looking for data. Well, I'm going to search for all the shutdown valves on this particular asset. I can have a call out there which shows me what it looks like, and I think I'll go to 2007C. So I'll click on that button, and this is all sitting in the cloud, and the original drawings were all in dumb PDF format. This may be taking a while over the webinar, but you can now see that I've found STV 2007C on this PNID, and I found it in a couple of seconds. And you'll see on the left-hand side in this tree view, all of those tagged items have been automatically tagged. It's got the tag number, and it's got the classification as well from the ICA instrument standards. So that's all been done automatically. And that's why I said early on in the presentation, the AI platform does all the heavy lifting. So that's all automatic, just happens once we've told the machine what to extract. So if you have a look down here, there's the object data down here. In this case, we've just extracted 3 pieces of information. It's an instrument, that's the tag number, and the description. We could, of course, extract a lot more data if that was required. And then what about repurposing of the data? Well, here's an example of a work pack, very simple work pack that's been put together to go and maintain this particular item. And what we can even do is allocate parent-child relationships. So there's the parent in the purple, I'll just zoom in a bit, and those are the 3 children, which gives us fantastic capability using a dumb PDF drawing to be able to go and find this information so quickly. So if I go back to that valve now, I can actually have a look at this within the 3D model, because I would have now understood what's going on in the PNID, or maybe I want to look at other drawings. And as you can see, if I click that button, you can see everything that's been identified by the AI platform. And I can click on a button to download an intelligent PDF if I wanted to use it on site. But what I can do is click on this button, and it will open up the 3D model, photogrammetry model, and it will zoom to that particular item. You will see that's STV 2007C. Now, the advantage of this is that this is really as built. This is what's out there on this platform right now. And you can see the quality of that text. You can read that nameplate very, very clearly. And I can now zoom around or swing around, and I can have a look to see, oh yeah, I've got some laydown area to lay down this big heavy valve, and what level it's on, do I need a crane, etc. So that's showing you now going both ways. You can go from here back to the 2D drawing as well, which Nick will show you just now. But that's very quickly showing you the power of the digital twin. So for the last part of this webinar, before we go to the questions, I'll hand over to Nick to wow you with some really, really impressive 3D technology.
Thank you very much, Richard, and hello to everybody on the call. I'm just going to share my screen. So yeah, what I'll be doing today is just giving you a quick demonstration of some of the different sort of capture methods and functionality that you can expect within a digital twin. So in this first demonstration, I'm just going to be moving through this main window here, and I'll be displaying photogrammetry and what that sort of looks like. So in this first example, we'll be moving through these red spots on the deck as I hover over them. You're going to get the pop-up window that gives you an example of what you're going to be looking at. Now, each of these points is a 360-degree image that's been captured on the deck of this facility. So we click down onto it, the screen is going to split into two. So on the left-hand side there, we have the top-down plot plan view, and on the right-hand side, we have the photogrammetric capture. So in photogrammetry, you'll see that one of the main sort of advantages of this capture method is the extreme quality of the image. You've got great depth of clarity there and the ability to read the sort of signage and the text as we come in and out. The images are also captured at multiple exposures, so you're going to be able to change the brightness in either extremely sort of bright sunny days like this, for example, so that it's not too washed out with the sun, or in a dark area as well. You're going to be able to increase or decrease the brightness to get a better look at what you're the area that you're working in. So again, the ability with photogrammetry is to really give operators the sort of extreme depth of knowledge and immediate clarity on the site that they're going to be working in. It's great for familiarization purposes, getting to understand a site, or by perhaps being able to completely avoid a trip at all by being able to visit and walk around in that full facility without ever leaving your office or your home space. One of the other benefits of the photogrammetry method is that you have the ability to take measurements within the images. Now, this is possible because each of these red points is actually one image on top of another. You'll see here as we toggle between the lower and the upper image. Because we know the difference between one image and the next, we can create points within the image and then draw lines between the two of them to give you an estimation of the distance between the 2 points. Again, this is going to be useful in the creation of work packs. If you're going to be moving equipment around the site and you need to work out it's going to be able to pass through a certain space, if you need to work out a specific laydown area, as Richard has suggested, or indeed if you've got a measurement that could be either hard to reach or impossible to capture otherwise. Now, that's just an example of the sort of photogrammetry idea, but within the digital twin, I understand that operators don't want to be tied to one specific data set. So you've also got the ability to build in the laser scan data as well, and point cloud viewers as well. So now as we click down onto these yellow spots, I'll be able to just talk you through these. So this is an example of a laser scan survey that's been carried out on an asset. Now as the laser scan is being deployed, the camera will take panoramic imagery, and this can be built into the digital twin to give you a viewpoint similar to the photogrammetry that we were just looking at. And then this can also be built in and compared with the point cloud data that has been pulled out of the laser scan. As I click on this icon just down here, we're going to get the image popping in within the digital twin, and you'll see that start to auto-populate there. So then in this situation, you've got the best of both worlds. You have the freedom of movement and the ability to sort of measure within the point cloud here. And then you've also got the clarity of the image from the panoramic viewpoint that's been taken as well. You'll see as well that the points that have been captured are available in both, and as you click through them, the point cloud will open in the same location as the spherical as well. So it allows you to compare across the two of them. If you've got two screens up whilst you're working on the asset as well, you're going to be able to look at both of them and have the ability to compare through the two. Another example of data sets that can be brought into a digital twin is the ability to work with 3D models. So for example, in this example, as you can see, it's been left on, and as I rotate around here, in the photogrammetric image, you also have the functionality of being able to overlay the 3D model into that if there's an XYZ coordinate set available. So as you'll see, what's happening here is that the 3D model is being pulled through and the intelligence is being overlaid onto the photogrammetric image. As I hover over each of the individual parts in the 3D model, it's going to pull through that information there. And again, you're going to be able to compare and contrast the knowledge with what's in the image there. So you've got the number tag here, ESD 86300. You can see that comes up on the tag there as well. Now this is useful because it allows you to compare and see the as-built environment against what you have in the 3D model. So for example, as we can see here, there's a box of equipment that has either never been placed or has since been removed. And that by being able to see that against the actual as-built model, you're going to get a greater depth of knowledge with a comparison against the two. Within the photogrammetric options for the digital twin and indeed the laser scan, kits can be provided that allow the operators to capture individual elements and areas of a site which means that there doesn't need to be a full deployment to keep the model evergreen and give you confidence in what's being looked at within the digital twin as well. But the real sort of benefit and the ROI of sort of the digital twin starts to come back when you're able to build in more intelligence and information into the images that you've got there, and that's when it really becomes really invaluable in creating work packs and increasing sort of familiarization within a site. And this is available in a number of different ways. If I just jump into this one here, we should be able to see an example of the annotation tools that are available. So as you see, if we go up to the top tab here, there's a range of annotation available from line to shapes to text, which can be brought in and then can be easily pulled out in a screenshot or a URL link and put into a work pack, which can then be shared with anyone else in the organization. You'll also see in the back here, there's an example of the tagging system available, which can automatically be placed within the images, again, with relation to sort of coordinates and an XYZ system, which can then be populated with any relevant information, for example, any sort of attachments relating to inspection reports or anomaly reports, so that anybody within the operator's organization can come in and automatically pull up any information that needs to be, that is associated with that piece of equipment. Including this, there's a number of plugins that can be available within the digital twin. For example, a live data feed from the Pi database. So as you see, as we hover over here, this is a sort of signpost to the external Pi database, which is pulling in the live data feed and overlaying it over this meter just here. So again, just giving you that depth of knowledge and understanding of what's happening on the site without actually having to visit and be there yourself. And then just as a sort of final example of different data plugins and integrations that can be brought into a digital twin, I'll show you the Digitex example here. So as we see here, if we rotate around to this piece of equipment just here, you'll see that the sort of tag on, or the writing on it is AOV 2007. And this Digitex tag has been placed onto there. We'll open up in the same way as the tagging system that we were just looking at there. And it has the link here for the Digitex Knowledge Hub system, which we can click onto, and it will automatically open up the associated PNID and zoom into that particular point there. And then what you can see as well is just down here, we've got the reciprocal R2S link. So if I just come out and close this one down, and then we go back into the Knowledge Hub system, onto the R2S link, we can click on there, open the client, and what it's going to do is open up the spherical point within the R2S model and auto rotate around to that piece of equipment there again. So at this point, I'd like to just sort of close out the demonstration there. Thank you all very much for your time today and listening to us speak, and I'd like to open up to any questions that you might have.
Yeah, thanks, Nick. That was amazing. Very, very impressive. So I think what you've seen here today is an overview of digital twins, what they're all about, what the benefits are, and how we can provide significant benefits to the operators and EPCs as well, and demonstration of what's available right now. So over to you, Kashma, to handle any questions.
Thank you, Richard. Thank you, Ru. Thank you, Nick. Chinazari, maybe you can read out the question. Chinazari?
Yes, let me read the question. From Tengku Salehuddin, he says, a commonly asked question is how the security of all the data in the cloud environment, I assume provided and maintained by Digitex, is guaranteed.
Okay, so that's a very, very good question, and one we get all the time. And the answer to the question really is it is as secure as your SAP S/4HANA system, because that's all in the cloud as well. And it's as secure as all your banking data as well, because that's all in the cloud. So there's nothing we're doing that's different to any of the other data that you're using. And in actual fact, being stored in an environment such as Amazon Web Services or Microsoft Azure means you have better security than in a third-party organization. So this data is not just stored on a server in Richard Beck's Digitex office in Perth. It's actually stored behind all the servers and the firewalls within either AWS or Microsoft Azure.
Good. Next question is from Mr. Aisamuddin. I can imagine capturing the 3D picture to present the exact location of the tagging involved in the 3D camera as the tool. Is the 3D camera an explosion-proof standard?
Ruth?
So I just want to check that I understand the question. So when for example, our team are photographing a site, they capture such a number of images, and they do that very quickly. But what happens when they process the images with our processing software? They apply XYZ coordinates throughout the images, and those coordinates are then aligned to a known reference point. For example, if there's an existing 3D model or a coordinate system, those images will then all be aligned with that coordinate system, and that then allows us to apply and automatically input information from other sources that also has that XYZ, or those XYZ coordinates. Does that answer the question?
Ruth, I think there's a second part to the question was, what happens if you're in a hazardous area? Are the cameras able to go into a zone 2 area? I think was the second part of the question.
Yes, so we use our surveyors use standard DSLR cameras, high-end DSLR cameras, but that you can buy. You know, anyone can buy those. They are not intrinsically safe, but we have worked with all the companies that we've worked with, Exxon, BP, Total, and so on, using a hot permit. So they're not intrinsically safe, but we use permitry and all the flashes within the camera, for example, are completely disabled. But yeah, that's how those work.
Okay, thanks, Ruth. All right, Nazari.
All right, next question. What is the initial investment from Mr. Anonymous? What is the initial investment that one would be looking at for a typical facility to develop digital twin, both in time and in cost?
Okay, maybe that's better taken offline, to be honest, Nazari, because this depends on what you want to do. But the approach we would take is we would start small and capture perhaps a part of an asset, and then do the same with a number of the drawings from that area, because this has all got to be business led. You got to make sure that we're delivering cost and safety benefits, because we're not, it's not going to happen. And all of the projects that we've done are all focused on that. So first of all, we look at, okay, so what business problem are we trying to solve? And that might be to say, well, these platforms are all remote, so it costs us a lot of money to fly people out every time they want to look at the asset. So what we'll do is we'll capture it digitally, and then you'll be able to save all that flying time and that sort of effort going out to site. And then on capturing the drawings, you might say, well, let's look at how much time is spent looking for data, and that's the 20% side that we had. All right, and we can save that. So it's got to be a business model approach, and it's got to be staged really, because no one would go and capture all their facilities together. And we're embarking on this journey with Petronas right now, where we've done a few of their facilities, and they do it one at a time. And every time we do a little bit more, and they get massive cost savings, and they say, all right, well, let's move on. So I'm not trying to sidestep the issue, but it's really something which, you know, we need to sit down with the operator and work out what the business problem is and come up with a plan to save them money in that environment. Ruth, do you want to add anything on your side?
Yeah, definitely. I think what we've shown today as well are a variety of different solutions. So, you know, as Richard says, it really depends on what the business need is. And we would very much recommend that a company looks at which challenges they're trying to meet and in which order. There's flexibility around what kind of from the sort of imagery side of things, as Nick said, there are a number of ways that you can make a visual model within a system like R2S. And if there is existing imagery or existing laser scans, you may choose to build a model with that. Rather than having a brand new survey done. So all of that then would affect the price. And obviously the same with any other systems that you might want to link in with, whether it's Digitex or do the work there. Obviously depends on the data and things that you have there. So that the price, unfortunately, very much depends on what you're looking to do in relation to what we've shown.
But just to emphasize that we would be more than happy to talk to the attendee separately and understand your requirements and see how we can help.
Absolutely.
Okay, Nazari.
Next question from a anonymous: how hard or easy it is to learn to operate the digital twin, and who are the department or personnel typically who would benefit from digital twin?
Okay, so a number of answers there. First of all, I would ask the question of where did you do your training for internet banking? It's no more difficult than that, right? You obviously haven't been trained for internet banking. You just go and press a button in the hole in the wall and you take your money out, or you transfer funds from your mobile phone. So the approach that we've taken, right, is that we require absolutely minimal training. And as far as the benefits are concerned, it's every employee in the organization that needs access to data benefits. All right, so that's from the designer who's trying to design a pipe to fit into the plant, right up to the engineer who's doing the engineering, to the procurement person who needs to order the equipment, to the material master person who needs to determine whether there's a spare part in inventory, and right across the whole organization. So, yep, it's really across the whole organization.
Very good. Next question is from a Tengku Salehuddin. The question is, what is the expected frequency for data are reviewed and updated, or is the update performed immediately when there is a change?
Immediately when it's a change. Now that applies, and I'll talk for Ruth on this one because I'm talking at the moment. If you were to add a new pump onto your facility or put a bypass valve in, you would then arrange to have the digital photographs taken when you do that change. They can then be uploaded. So you don't have to come back to Ruth's team to say, please send a team out to come do the photos. That's one of the very, very big cost saving advantages certainly on the 3D side. On the 2D side, what you would do is once the drawings have been approved for whatever version you issue in them, they would be published to the AI platform to extract the data. So it would be on an ongoing basis. Is that clear enough, Nazari?
Should be good enough. Right. Next question is from a Amir Hisham Al Bakri. He says, "Hi everyone. Ruth and Nick might remember me. Keyword Innovim. How did you get the dimensions on the 360 photos?"
So in terms of the measurements, so the process of photogrammetry involves capturing the photographs at 2 different heights, and those are always exactly the same distance apart. So the tripods that our surveyors use are calibrated so that the distance between the images is always exactly the same. When we process the images through our software, the software knows the distance between the images, and then through I mean it's really mathematics, but it's through, you know, so through triangulating those measurements, it can work out the distances between different points that you would select within an image, and that's really what photogrammetry means.
Yeah, good answer, thank you, Ruth. Yeah, so it's all about reference points, really.
Now, next question is from a Shamsur. He says, can the SaaS from R2S, AI from Digitex be hosted at a local server? Is it about data sovereign issue to oil and gas company?
Yes, it can be hosted locally. I know Ruth and them have. From the Digitex side, all of our clients have preferred to do it in the cloud. Quite strangely, because they feel it's more secure, but there's no problem. Our technology can be deployed anywhere.
Yeah, so I think maybe 2 of our customers host their data themselves. We have customers in Indonesia, and in Indonesia, you know, they have to host it in Indonesia, so they do it themselves there. And we have other clients that, as Richard said, I mean, it's quite an outdated view, I think, that the cloud is not secure, and so some of our older customers have hosted their own, but they're now also moving on to our hosting service. But yeah, we can do either.
Thank you. Next question is from Anonymous. Is your system only for the oil and gas industries? Can it be integrated with real estate development?
Yeah, absolutely. I think the real estate industry is a lot simpler. I'm not running it down. It's just that facilities are very complex. They're offshore, and certainly from the Digitex point of view, it would be a lot easier to process documents in the real estate world. And I'm sure Ruth would agree that they could easily capture. I mean, Ruth, you might want to just quickly mention how your company started right in the beginning.
Yes, thanks, Richard. Yeah, so the software R2S was initially developed for the forensic industry, and it is still used in that world, mostly from police forces in the UK and the US, but we do have some in Europe also, and they use it to photograph crime scenes. And then they populate those photographs within the system, and they're able to return and add in information about the crime as they find it. Once they've, if they've identified evidence, for example, they update it and manage it as they go. So we still do some of that work, but because our business is based in Aberdeen, and obviously it's a big oil and gas hub. It wasn't long before the software started to be used by oil and gas companies. We are also working with offshore wind. We've done some bits and pieces for construction too. We've never done real estate, but I know that it's very popular there. And I think some of the self-capture services that we have really would enable any company to pick it up and use it for whichever purpose. But oil and gas is definitely our main focus, I would say.
Yeah, I think mining is a big area for us as well. We've done a lot of work in the mining industry as well, which is very similar to oil and gas, and sort of hazardous areas, big plants, so it's very suited to that.
Okay, next two questions are from MOGEC President. Question number 1. Based on experience in UK and Australia, what drives this migration to use digital twins as it requires investment? And how will technology related to digital twins impact engineering service providers? How can we use digital twins to develop technical training?
Okay, no, very good questions. Thank you, Mr. President. Very good indeed. So first of all, the digital twins are used for a number of reasons. Number 1 is safety. All right, you can find out very quickly what's going on an asset. You can have a look at the asset in 3D. So, for example, if you do have a serious incident, you can look at escape paths from the affected area. So, safety is a very big topic and a very big area which we use digital twins for. And the other one is simply cost saving. Right, there's a massive, as we said right at the beginning of the presentation, there's a huge drive on reducing cost. And so what organizations that we're talking to are saying is, well, how can we shorten the process? Because artificial intelligence doesn't get rid of the human being. What it does is it automates a lot of the processes. So how can we automate a lot of these processes to make them shorter so we can drive down the cost? Now, we are working with a number of EPCs who are being very smart about it and come to us, and what they're doing is using our technology to shorten their processes. So they can either bid low on projects or increase their margins. So very smart EPCs are getting on the bandwagon and making a huge benefit to all of this. What was the third part of the question?
It was around training.
Oh, okay. Yes. Well, I think Ruth can probably answer that better than me, because that's a really good question, especially on the 3D world.
Yeah, it's a question we often get asked, and I think, as far as we're aware, our customers often use the visualization element for induction and certainly familiarization of site. And linked with what Richard said about a key driver being safety, it really supports that to help people understand what the site looks like, where they're going, where the muster points are, for example, where the safety equipment can be held, and so on. So, and then in terms of a training tool, really, you know, I think it's quite wide in terms of how creative the owner of the software is. You could very easily, you know, have people demonstrate knowledge of procedures and you know, access to equipment and talk around their knowledge using a software tool like R2S, for example. There's no sort of, there are no definite training programs that I'm aware of that any of our customers have used, for example, but very much on the induction side and so on. But I think it would be very easy to sort of drive simulation and that kind of training through a digital twin also.
Thanks, Ruth.
Okay, next question is from somebody, I believe from Petronas. He says, hi, I believe Petronas also developed in-house the same platform as you shown just now. They call it Omni VR. How do you differentiate your solution from it?
Yeah, good question. I'm not really familiar with Omni VR, but I don't know, Ruth, if you know anything about it.
I'm afraid I've never heard of it either. So I'm not sure I can answer that really.
Yeah. Okay, we'll have to get back to you. We'll do some research on it and get back to you through MOGEC. Okay.
Let's move on to the last two questions from Mr. Azmi. Question number one, how about the system security, as most companies has their own ICT policy? And question number two, this digital twin technology can be for monitoring and visualization only. Can it be designed for remote control and execution as well?
Okay, all right, let's answer those two questions separately. From the security point of view, you'll find that most of your operating software is on the cloud anyway, right? So there's no difference as far as the security is concerned. And we've also said we can deploy it locally as well. So it really comes down to a business decision with the operators to, you know, where do you want this located? How do you operate as a company? What are your security processes? We've passed the Shell, Chevron, and Impact's security tests. So those are pretty stringent. So I think just that gives us a good benchmark that we're in the right area. As far as remote control, yes, we don't, as Digitex, or get involved in the operating systems, because those are done by specialists in that area, and those are certainly under control at the moment. If you look at Australia as an example in the mining industry, where you operate all the trucks, all the trains, all the ship loaders remotely from 2,000 kilometers away. So absolutely, yes, control is a key element of the whole digital twin strategy. What has been missing, and what R2S and what James Fisher and Digitex are bringing to the party, is feeding the engineering data up into the overall digital twin. That's the really missing link, is what we bring into the party.
Okay. Next question is a statement from Amir Hisham Al-Bakri. He says, Omni VR only use 360 photos?
Okay, so if assuming that is the case, and going back to the question of what's the differentiation, Omni VR is using 360 degree photographs, which obviously the system that we've shown today has also. What I would say the differences are around the ability to take in imagery of different types. So we take in, for example, our own survey, which is photographic, but we also take in laser scan survey also, as Nick showed in the demo, and we can overlay with a 3D model. But I think the real difference around, other than the sort of different kinds of visuals, is through the ability to integrate with different systems. So the integration, for example, that we have done with Digitex really makes sense for the software, because we're able to integrate that really valuable data in a system that has really great use case while also making it available with the photographic images. So I would say the differentiation is really around the way that you can layer in data from a variety of different sources and systems. So if we go back to the BP Angola case study, they integrated their Bentley ALM system, SAP, and with Digitex as well. So I think that probably is the main difference, but please don't quote me on it, because obviously I have never seen Omni VR, and maybe it has other capabilities, but that's where I think the real differentiation is from the very limited amount that I know.
Okay, next question is from Ayman Azid Zudin. He says, hi, can this software be used to extract data from SP3D, SPI, Smart Plant, REVIT, BIM software?
The answer is absolutely yes. We processed 560,000 isometrics which were generated from a Smart Plant 3D for the Rapid project. So yeah, we absolutely can do that, depending on what you want to use that data for.
Very good. Next question is from Anonymous. Apart from just presenting a virtual representation of a platform, does R2S has planned to advance its software function with real-time simulation capabilities?
So yeah, so we're able already to integrate with live stream systems. So Nick showed the example of Pi, and we can also integrate with CCTV systems. So you could effectively have the live stream of a video footage from the site within R2S as well. And there's other development that we have done relating to a visual positioning system as well, which the survey that we would have done with photography, then we can align that with somebody who's wearing a body-worn camera as well to track where that person is. So that's a bit more of a sort of, I mean, it's almost ready, but it's probably quite a future development really that that we're really just starting to sort of pilot now. So yeah, but in terms of actually having the live streaming imagery, which I think is the question, we would do that currently through a CCTV or similar plugin.
Very good, thank you. The last question now from Shamsur. Have you heard about VAM2 from Germany, and how do you rate them?
No, never heard of them, sorry.
I haven't heard them, sorry.
We'll have a look at that.
Well, all the questions that we have now. And we are about the end of the session now.
Yes. All right. Okay. Thank you, Cik Nazari. Thank you, Ruth and Richard, for answering the question. Thank you, participant order, for the questions also. As the saying goes, to every beginning there is an ending, and now our webinar has come to its end. And once again, thank you all participants for participating in our webinar. We really appreciate it. Thank you again, Richard, Nick, Ruth, for presenting to us.
Thank you.
I look forward to seeing all of you for our next event. Stay safe. Wassalam, and thank you very much.
Thank you, Richard. Thank you, Ruth. Thank you, Nick. Bye-bye.
Yeah, wassalam.
Thanks for having us.
Cheers.
Take care.
Thank you. Cheers, bye.
Can we stay back for the rest of us?
Yep.